Today, we are going to talk about growing open source DP ecosystem on ARM. I'm sure you are aware that ARM ecosystem is expanding and it is gaining quite good attraction. A lot of open source projects are already being ported to ARM, and including databases. But it is not only the mainline database, but along with the ecosystem that they carry, especially the supporting tools, are also being ported to ARM. So let's try to understand what is the state of these open source database, what is the state of the ecosystem, which all tools have been ported, what things you can expect in upcoming days. And of course, we'll try to understand importantly the performance aspect, what performance you could expect. And is it a right time and choice to consider ARM? My name is Krunal Bauskar, and I've been driving this cycle on ARM initiative. That's quick intro about I've been working in MySQL space more than a decade now. Currently, I'm working as part of Source DB group. In past, I worked with Percona as PXE at Oracle as InnoDB at Yahoo Lab as Big Data Research Engineer, as which is now part of Teradata, where we develop the world's fastest storage engine, and more such. I've been driving MySQL on ARM initiative, which includes MySQL database, MySQL, MariaDB, Percona, other ecosystem tools. Percona and MariaDB conference, and of course at the so, quick intro about me. Let's move on to our today's agenda. Sorry. So, why ARM is gaining importance? We'll try to understand that, and then we will talk about which open source databases already have presence on ARM and what is the state of them. And then we will try to understand the ecosystem that is evolving around them. And then, of course, we will talk about the performance and cost, because that has been the key motivation factor for any end user to consider ARM. Then we'll talk about community support and how community is evolving. And then we'll end it out with some quick note about future work. So then let's get started. So why ARM is gaining importance? So what does it come to your mind when you think of ARM? I'm sure majority of you would think about cell phone and network equipment, and majority of our cell phones are powered by ARM. Now, if you stretch it further, you would realize that a lot of housing appliances and IoT devices also has ARM. And if you stretch it further, you would discover automobiles, defense, space has also quite a good number of ARM processors being used. In fact, with a growing number of self-driving cars and smarter devices, ARM is being used on wide variety of applications. What's something new is high performance computing. So when we say high performance computing, it typically includes software which needs really a good amount of computational power, or whether it's a big data application or whether it's database or for that matter application servers. So this particular vertical was not, I would say, very frequently used, but now the ARM processors are getting more and more faster, and probably also there are more numbers of cores are getting added, they are getting more powerful. So this new vertical getting opened, and of course the motive behind it is the power per watt, or sorry, the per watt provide. You all know that ARM pretty less power even turns out to be a low cost of ownership, and then the motivation, and with ARM processor get powerful, the in a perfect choice to also explore its usage high performing. But what has triggered this thing? Few years back, if you want to go ahead and get a ARM based machine processor, then you'll probably have to go and get it, buy it from market, and which was a costly affair that. But in last couple of years, cloud provider providing ARM based instance. For example, Huawei do provide cloud do provide instances high silicon Kunpeng 920. Amazon do provide instances to Amazon Gravy Auto. Oracle also announced that they will bring ARM into Ampere Ultra. Instances are also available .com. So that availability of ARM instances through cloud provider just made it easy for to go ahead and start. It also helped, like developers would, in this, let's say, could, things, but then what about the user? The complete, both the and developer side can easily boot the instances on and start harvesting of ARM. It is limited to that, but in fact, couple of years also, all major OS vendors have now for ARM. So it's all the basic you need are also made available on ARM, and there are multiple being ported now. Really, sometime back, this Hadoop made an official release ARM, so that actually opened up a way for Hadoop base to now start supporting ARM. Now databases, will also see about them, but most of those major database are already supported. Then load balance application servers. So it is very important understand that ARM, the key motivation is that ARM cloud instance has potential to around 30% of cost saving. And another important point is lots of data generating devices are all ARM. So having a data processing devices also on ARM help circuit complete. So you can have everything moved to the complete, end-to-end and being ported or run ARM and achieve a significant by running everything in a single environment. So and let's understand this typical question most of the user has. ARM for quite some time, then why is it so long for software port to ARM? ARM is also a little Indian, so if you a software works on x86, let's say, you try to compile it on ARM, with pretty probability it will get compiled and you will be able to run it on ARM. Problem is, if you want to get the possible performance out of software, then of course there are few tuning that need to be done. These are the challenges for any software to optimal performance. And why is that? Because ARM is a memory model as against longer memory model that exists. Also, a lot of low-level codes which have been typically x86, simple timers, spin loops, and all. So that also needs to for ARM. Now it's all about more cores. So when to more core, your software should able to actually harvest a power of more cores. So typically using the parallelism, and along with more cores, we get more NUMA nodes. Software should also understand. Okay, well, there should be as much as possible less or the cross NUMA access, because NUMA access has its own latency. Beyond that, there are times when you want to use instructions. These are low instructions, so these hardware instructions would be, if the made compartment tuned for x86, the 86 compatible. These instructions are different, instruction set is different. So sure, the instructions are also used is it. And ARM do a neon library, which is realization library, so that a facility could exploit it. Now of course there are other caching pipeline differences to be understood, and accordingly the things needs to be tuned. So for most of the database have been working specs for more or some level, and which we of course we are getting performance. Maybe it's not optimal performance, but we are the decent, and of course we'll see them to the numbers. So with that, let's understand open source database and their presence on ARM. Now, of course, this is not the complete picture of all the open source database that are present on ARM, but we are primarily considering the leading and the databases, and something which is of more of our interest. For example, MariaDB, MySQL, PostgreSQL, MongoDB, and Percona Server. Majority of them already have official packages on ARM. But let's understand what is the state of each of these databases. So typically, when a user would like to move from one DB system to other DB system or environment or setup, whatever you call it, user would like to think it that okay, am I going to lose anything? Especially, user will evaluate the system in form of like what are the pros and what are the cons. And I would say it is easier if we can actually look it from these four perspective, and that should able to help ease out the process of whether it is the right thing to move from one DB setup to other DB setup. So feature set, performance, ecosystem, community support. Let's understand what we mean by each of them. So when I say feature set, it means that am I going to lose on any feature just by moving from my existing setup to a new DB setup? In our case, this is on ARM. Sorry. Performance, of course, no one want to lose on performance, and so that's another aspect, right? Am I going to lose on performance, or would my software scale in the same way as it was scaling with my existing DB setup? Ecosystem, as I said, database is never a standard component. It has a lot of other surrounding component, and that makes a complete DB system. Now whether it's monitoring, load balance, whole lot of other things. So it's important to ensure that when a database is moved to a new set, all these components are made available on that particular environment too. Last is the community support. So this is one of the major thing open source project. So typical the why projects are so successful been because of the community that it has along. So let's say typical if you have in a question, post it on community, and there are people who would blog about it, write about things. But if you if you post it in the community, there would be people respond back if they have encountered similar or so. So it has been so that communities are very important when you want to consider moving on new environment. So let's understand state of different data by looking at from these four perspectives. To talk about MySQL, MySQL have been releasing packages on starting 8.x. So MySQL have official packages um, for ARM with 8.x. So MySQL is feature complete. We are not aware of any feature that is beta or experimental for ARM. Efforts done by MySQL side to some of the community patches, and most are performance patches and will help improve the performance of my on ARM. But a lot of more patches still in the queue. We are happy, like lot of that MySQL has been doing are considering that be that the MySQL later or have to be run on more cores, so it has to be scalable. That so like use of distributed counter, which actually or which is meant design in such a way that it ups to the multi-core, or more NUMA architecture is important. Will be addressed or getting addressed with the same priority like the other architecture. In fact, since MySQL do support it, you can a pretty the same priority for other architecture. Now supporting tools wise also MySQL we have done good things. So MySQL route, MySQL shell connectors, all these things are also available on ARM. And there is a dedicated on ARM channel on MySQL Slack. So you can of course connect to that and post your question, and someone from the community will answer back to you. So overall, I think MySQL is in a good state when it comes to ARM. Now let's talk about Maria. So DB also have official just on ARM. It is feature complete. We are not aware of any feature that has been marked beta or even experimental for ARM. In fact, MariaDB is a winner in optimizing this data on ARM. So they have already accepted a lot of patch from community have already did their own settlement, and now I think MariaDB we can say pretty optimized for ARM. And not only that, even their research or the new development they're trying to do for normal MariaDB server, they do consider ARM one of their and they do evaluate development on through community support. Where they do lack is the tools which might be beyond the server, like Max is their load balancer or the Connect, are not yet ported ARM. So getting them would also help get the part of the ecosystem. Uh, there is support for distro for most of the flavors of CentOS, and those are supported. Beyond that, there are more and we that MariaDB is working on adding support for more distros, so we can more support getting added by MariaDB to a dedicated MariaDB on ARM chat on MariaDB community Zulip chat. Percona server. So Percona server don't yet officially have packages on ARM, but it is community evaluated. I myself have tried and it works on ARM. In fact, it is one of the widely used by community when it comes to MySQL. It has been tried on varied architecture of ARM or varied ARM hardwares. Also, a Percona server is fully upstream compatible. That means changes or fixes done by upstream for ARM will, of course, be inherited by Percona server default. Percona server has a pretty good number of supporting tools. Now, with the extra backup, PM, which is their monitoring tool, Percona toolkits, and all of them works on ARM. Again, they are been minute evaluated, or sometime even Percona engineer evaluated. So I think that's a very good state to be in. Now let's talk about PostgreSQL. Now this also has official package in ARM through their repo. It is also feature. Postgres is also open to accept ARM already for some ARM. There are some ARM optimization that Postgres has already accepted. They also have a pretty active community, and which is gain and ARM in just been gaining good traction there too. it scale in line other architectures. So we'll of course see the numbers of how it scales. And Postgres ecosystem is a multi-vendor ecosystem. A lot of tools comes from vendors, but when we tried looking at some of the different and major tool, we found that them are available on ARM. Also, would like to make that there are some tools which are available directly from the repo. There are few tools which are also available from the respective distro or OS repo made available on ARM. It's pretty much possible that whatever tools you like, if you really look for it, maybe these two repos, Postgres repo or OS repo, you find it available on ARM. MongoDB. So MongoDB also have official packages on ARM. It is feature complete as per our reading. It again scale in line with other architectures or like other architectures also on ARM. And some of the ecosystem tools are also available on ARM. For example, the MongoDB database tools. So with that, let's try to understand, sorry, the ecosystem or evolving ecosystem. So when I say ecosystem, actually means if a user like to move on to for a different data, there are the remaining component the way we are made available on ARM. So we have considered a couple of examples. This is the example of MySQL. So of course we know server is on ARM. But if you talk other things, for example, solution, so whether it's a binlog representation or InnoDB cluster, they are inherent to MySQL. So SQL server is available in ARM. These are coming with it. For backup, you can always use Percona Extra Backup. It works on ARM. On load balancer front, Proxy SQL is offering official packages on ARM just couple of months back. MySQL router official on ARM. PM Percona monitoring and management. Again, it's community evaluated. I know it works on ARM. Connectors official pack are available on ARM. Tools now toolkits works on ARM. MySQL shell the packages are available on ARM. If you look at every category, one or of software at least are available on ARM, and all of these softwares are all open source. I want to do a transition to ARM using only open software, then of course all of it's you will be able to find all kind of software of all varieties or all keys. All the categories you will be able to find or two softwares which are available on ARM. Means you are not lose anything. You will be able to function in the way. And most of the software we have considered are the most common software that user is using. Beyond that, environmental tools, if you are using MySQL instances to like Kubernetes, Docker Swarm, or using some kind of orchestration doing it, then most of those products are also available on ARM. So that means we can have a FAQ user software made available on ARM. In same way, if you look at Postgres, then Postgres server, of course, is available on ARM. On HA front, Rep Manager, Tool2 are also available on ARM. Backrest or PG Backrest is also again available there. Bouncer, which is load balancer, available. Monitoring, we talked about PG Admin also available. Connector is also are available. PB tool, whether it's PG Loader or PostGIS, are also available. On the environmental front again, if you are using that, then as I said, Kubernetes swarms are already. So we can also from that, okay, we could also enable Grace based ecosystem on you know if you feel okay, so I have not captured all the possible software. There are software available on ARM, just part of them. And but the good part is the list is expanding. So let's say you have 10 in some categories, maybe current 3 5 softwares are made available, and in due course of time the things has caught up the pace and the traction, and getting interested ensure in another few months, but certain software is not available, surely be made available on ARM. The important point is with MySQL or Postgres, MongoDB, this ecosystem itself is growing, and you will not feel that okay, it's moving on to ARM. Am I losing something? Because most of the more popular or tools that you are used to are available or available on ARM. Also, as I said, more databases and tools are getting added. Community is expanding. This is very important. So pretty good traction has been seen in the community, and a lot of new users are joining the community. And every it's like users, not only users but developers are also present. So the community as such is expanding. Also, one good thing that happened in the past couple of months is Apple introduced M1, which is their first ARM chip for the laptops, and now your laptops or the Apple users will whenever they move on to this new thing, will have a ARM based desktop at their place, and that will further accelerate the development, because they could try a lot of things, and it would be further fuel the ARM adoption. Cloud offering is getting traction from enterprise users too. So so if you, most of the softwares, I'm sure you'll be using open source, but if you have a specific software which is probably enterprise only, then of course yes, they are also, so enterprise users are also considering moving some of those things to ARM. And vendors are getting more and more interested, so they will be supporting more things on ARM. Vendors are getting interested to port their software on ARM, given the growing user base and the community is expanding, and the kind of course, the motivation that ARM provides from the performance and the cost perspective. A quick word on the migration. So as I said, it's a little Indian. So really, if you look at, there is nothing major in terms of, or anything that is involved when you migrate from a x86 RM. So typically upgrade or want to add extra server to your Excel cluster. Probably you boot the server, you allow catch up, you make it slave, you allow it to catch and eventually maybe you will make it a master. And that's that simple steps you follow. I don't think the like steps are almost same when you think of ARM. So you could provide an ARM instance, put a slave, allow it to catch up, and someday you can do master and everything will work. Importantly, there's no MySQL basically for this technology to work. It is all deprecation it has nothing to do with the processor, so that replication protocol is a independent. So from that sense, it is just like adding an exchange to a club. Now whether it is coming from x86 or ARM doesn't matter. On tool front too, a lot of tools, as I said, are already ported to ARM. They do have official packages, they work with them. In fact, if you that some certain particular tool is still not available on ARM, you can still continue using on x86 till it is available on ARM, because anyway the underlining DB protocol, they are nothing to processor, underlining process is being used. Illustration wise also, you can do mix and match of instances on Docker VM, where we have been personally trying these combinations, running few things on Dockers, and maybe running on sorry, MySQL instances on six on Docker instance, and then using Docker and running and connecting to for with AIMs. So all that kind of match works fine. And there's nothing like okay, just because current hardware headline, there is a problem, to be some special steps that you it just work harmoniously to. Now let's talk about the most important topic, that is the performance. And as you are aware, ARM is this is a quick picture presenting cloud providers. If you try to consider for a same flavor, if, instance ARM and x86, that ARM cheaper than, of course, the range, but you can around 30% save for it. Let's plan this bet using a simple data point. For example, on Huawei Cloud for 300 USD yearly, you get x86 VM, which will have 12 VCUs and 40 GB of memory. For same, you would get 24 VCU of ARMs and 48 memory. So same amount of memory, but more of cores, and in almost that if it means also almost the computing power. So that that is the your saving, or that you can expect from ARM. For same cost, you are getting double the computing power. Now, if your software is able to use this extra computing power and more performance, then you can say I have achieved a cost saving, because for perform cost I have said, just by moving on to ARM, I'm getting more performance. So we actually we tag it as this particular thing as cost balance model. We will, you can put details about it, but the key idea is by keeping the cost constant, all other configurations and resources constant, and only allow uh, computational power to we will try to compare ARM against 86. This is just to get an idea as to that by keeping the cost constant, if you get a computational power is really helpful. Okay, and we'll see with those things with numbers. But why CPM was the question most of the time we get, and the point is uh, See CPM, sorry, if you talk about x86 and they, if you try to compare them, it could not be a direct apple comparison because there are different processor generations, there are frequency differences, there are hyper threading, and versus ARM doesn't have this hyper threading. And now Intel or x86 has turbo modes. And then there are NUMA arrangement differences. So with growing number of cores, maybe x86 you may have two cores, sorry, two NUMA nodes, but then for cost you probably get so many cores in ARM that you may have four core nodes. So all these things are different. So it is that we keep the cost constant, allow the computational configuration to change as per the by keeping the cost constant, and let's keep the parameters constant. And if software could get us better improvement through that. So we have benchmarked MySQL using sysbench and PG using pgbench, and typical how workload is. So we have considered CPU bound workload, all five cases of sysbench, and of course I have not quoted pgbench, the three case pgbench, and machine configuration. So if you look at here, for the same cost, so we have kept the constant. So for the same cost, we are getting 28 vCPU of x6, and for the same cost, we are getting 60 vCPU of ARM. That is 0.25x more cores or vCPUs of ARM. Of course, the memory is constant and storage is all same for both the machines. Now that extra computing power that we got, let's see if, if the database are able to use it. So these are results with MySQL.0.21. Now this is with uniform. So if you're of the uniform means that it will touch majority of the data and lot of would be done. And of course this is with CPU. So that means the complete data set is in memory. And as you could see here, blue line represent ARM and the represent x86. And it's pretty much evident that ARM continue to beat x86, especially once the certain scale point is crossed. ARM continue to significantly beat x86, and in some point the difference almost 2x. In fact, for write workload, ARM continue to beat x86 even with lower scalability. But for only workload, once certain scalability point is crossed, ARM is beating x86. Now that is uniform IO bound. When I say IO bound, that not complete data is not memory, so there would be a lot of IO. And even in this particular case, you could that ARM scores x86. The other is Zephian. Zephian is the pattern will touch only of the data. That means only a part of that will be touched, but that also means more contention. So uniform was lesser contention, Zephian was contention. So let's understand with more contention, can score. And as we ARM is consistently able to score even with more contentions. And this is Zephian CPU bound, and have Zephian IO bound. Zephian IO bound 2 ARM is able to consistently beat x86. And this is TPCC, a different kind of workload. And again here too, with growing scalability, ARM is able to beat x86. In fact, for higher scalability, the difference is almost 2x. Now that's Percona server. So Percona server, this again uniform CPU bound, um, consistent beat x86, and that's MariaDB 10.5.8. And again, the same pattern observed. A significant difference is observed between ARM performance and x86 performance. And this is Postgres SQL. So PostgreSQL for select, no doubt ARM is able to beat x86 after the security point is crossed. Uh, for simple update and TPC, we have two graphs. One is the blue line, which is the baseline, and one is the ARM patch. So you could see that the baseline thing, after higher scalability, ARM actually falls down, and that was because there was a bottleneck, and patch for it is already submitted. If the patch get accepted, and I'm very hopeful about it because it improves the performance in pretty good range, roughly 40%. So for higher scalability, you could see how the graph getting corrected by following the dotted line, and you could see that with the patch thing, AM is able to beat x86 even for the higher scalability. So what all these things mean? We say that okay, well, ARM is getting you more TPS. So if you put it in other words, this is a simple data point I got. Effectively, what you are getting is for the same cost, you are getting more TPS, and that effectively means your TPS per USD is more with ARM. For a simple example, we considered this is like MySQL again 8.0.21 uniform CPU bound. You could see the TPS per USD is 42% higher with ARM. So for the same cost, you are getting 42% more TPS. In fact, it is further higher. We've considered one data point, but 42% more TPS. And another way you can say that I have got a cost saving of 42%. So it is more TPS at same cost. Let's understand from another perspective. See, when you hit a problem like scalability issues, then what probably you can think of is like, okay, I need a more TPS. No, the traditional approach is go get the newer hardware, but of these newer hardware or extra cores will come at extra cost. But now your solution, when say switch to ARM, same cost, so you don't invest more, the same amount of things, database, same environment, nothing changes except the process, and get more performance. And of course, some of the users were wanted to see what happens if you try to compare him by an x86 by giving him computational power. And of course, here what we did instead of keeping the cost constant, kept the uh, sorry, we kept the computation and power constant, and of course the other other parameter remain constant, and allowed the cost to differ. So the saving could be immediately realized. Of course, ARM is cheaper than x86. So we, as you could see, x86 we have given 64 vCPU. In ARM2 also we have given 64 vCPU. Other configuration more or less remain the same amount or same kind of. Now let's see. ARM is really powerful. It will be able to also beat x86 same number vCPU, and it does. This would be a surprise to some of you, but with MySQL 8.0.22, this is something recently valued. So we have used the latest GA. And as you could see, ARM is able to beat x86 for higher scalability. For lower scalability, maybe it is lagging, but once it's a certain scalability point, ARM scales better, and it is able to beat x86 for higher scalability. In fact, for it an update non-index use case is able to beat x86 even with a lower scalability. Except the read write. Someone would say that, well, I see a small curve where on for higher scalability to x86 is better than, and I would say yes, that gap is like a 12% gap. And there are already, this is like not MySQL is not a best optimal tuned for ARM. There are a lot of patches that are still with, and we did so when we did we just a couple of patches and we could reduce that gap from percent to 6%. And there are more such patches. So as and when MySQL do start accepting patches and integrating them, this gap is for going to reduce, and I'm sure the ARM will cross x6. But if you just keep that thing aside for other use case, even now without all the patches integrated, you can see that ARM is constantly able to beat x86 for higher scale. So that is like for computing power, but the cost ARM continues to be t6. So this is the message that is coming up. Any flavor. Now it's MySQL, Percona, MariaDB, PGSQL, any workload, CPU or IO bound, any pattern, read only, read write, any configuration, contention, non-contentions, any setup, single node, multi-node. Now we also saw cost constant and compute constant. So whether you consider a cost constant like the CPM way, or you consider the compute constant, one which we just saw recently. The message is very clear. ARM always score. See, ARM is not meant for certain workload or certain kind of applications only. ARM is meant to help you across the board. So whatever is your configuration, whatever is your low workload, whatever database you're using, whatever setups you have, ARM is always going to score. Let's talk community. So as I said, community is pretty activity and it is expanding. More and more users are getting added beyond ARM community. Yes, MySQL have itself has 30 plus community performance. MDB has got a lot of community contribution, and most of them MDB or MariaDB has already folded. Our tools, even their popularity, community already evaluated them against ARM, and community by probably trying them with different actions, and so PGSQL too have started action where community have started calling patches and all. And the community, which consists of users and developers, actually grows across the globe. It is not growing like that okay, certain people who are interested are just doing it. It's the globe. Everyone probably wants to try it. Good thing is like, see, ARM itself open has an open model, right? So ARM has its own open ARM also has its own ecosystem and has its own so some point in time, let's say you are able to find a quick solution to some problem which you are facing, you can of course all it out of ARM community. And ARM itself also carries a community with Android own big community, now Apple community joining in. So general as ecosystem or company is just going to grow. Because already we see a lot of good traction on DP on ARM community kind of thing. So the way we evaluated, like, so we have evaluated all these things on the four main parameters, and you could see all of these databases have been able to qualify on all of the four parameters. So we can actually say that pretty much we can start considering ARM from the perspective of these four parameters, and all the needed things are available if user think of moving to the new DB setup. Future work. Now, a quick word about future work. So, vendor community continue to work on more tools. Now, of course, server optimization is a mainline focus, but optimizations of tools is also important. So that is also being worked out. More performance patches will continue. Feature that could exploit more cores. Especially parallel query or so. They mainly are for more cores. That would also help improving distro support. We talked about it that we believe the distro will be extended further. Support for supporting tools like shredding or Kubernetes operator and all. More open source database. We just consider few of them, but more database will get added, and more storage engines. Like for example, S3. We recently tried it, and it does work. With but of course it is marked beta sorry gamma or alpha quality, something of that sort, not in GA by MariaDB, but we tried with the RM and it is working in columnar storage and RocksDB, so all of these things. So there are, so this is where we feel that the future, so a lot of good things are planned. The things are just going to get better and better. More, you could harvest, you expect more better performance, more better functionality from ARM. So with that, let's throw open the session for Q&A. Of course, before that, you can remain connected. You can read more about MySQL and ARM through the blog, and you can also follow or join the Slack channel. These are MySQL on ARM and MariaDB on ARM. You can reach me on email and follow me on Twitter and LinkedIn. Before we end out, thanks organizers and sponsors making this and providing opportunity to share. Yes. Thank you.
All right. Thank you, Krunal Bauskar, for signing up for MinervaDB Athena 2020. Good to talk to you. Great, talking to the database performance engineers is every day something new, a lot of information for the community. I tell you why, right? One is the ISVs who makes optimizer more faster. Like for example, if you take the case of MySQL8 histogram is giving an alternative thought for indexes, how indexes work. Same is for the PostgreSQL 13. They have advanced indexing methods which does parallel vacuuming of the indexes created. So if you look at ISVs are on a very aggressive space of making database infrastructure more fault tolerant or pardoning, more tolerant, actually, right? Now, when it comes to talking to someone who comes from the infrastructure point, right? You are making an infrastructure which is built for faster computing. Like when you're talking about ARM, right? ARM computing infrastructure. Something which comes first to each of the production engineers or data SRE, including me, is like, look, if I'm doing 60,000 transactions per minute on a processor, then processing infrastructure, then it's going to be 3x or 5x on a different scale. Can you share us, like, how do I use old school capacity planning metrics as a yardstick to measure the benchmarking of an ARM computing?
Sure. So the two aspect we will try to consider when we talk about ARM benchmarking. As you know, ARM is all about cheaper in terms of the performance per watt is better with ARM, And so from that sense, the ownership cost of ARM is also less. So if you look at all the cloud providers who offer ARM instances, ARM instance is cheaper by a range of at least 30% when you boot same class of instance against x86. So if you want to go and measure it, so we can look it from both perspective. One is we can keep a cost constant and we could fetch out the extra cores, or basically the extra computing power that we get from ARM. And of course, your software, if it is tuned, fortunately MySQL, MariaDB, all these things are already tuned, so they can harvest the extra power, because they are actually meant to, or they have started getting developed for handling more number of cores, right? So in a sense, you just take your software, run it on ARM, and you could see the impact of around more than 30-40%, and in some cases it is like almost 100% benefit in terms of TPS you could see, by just because there is an extra computing power coming up. And if you want to say that, okay, well, I want to, and of course it is a cost saving, because you are getting more TPS for the same cost, right? And but then part of the time you would say like, well, I want to keep the same configuration just to compare. And even there, ARM is hits, or basically scores are for x86, especially with higher scalability. So ARM continue to scale way better than x86 when it goes to higher scalability, even if both of them are using the same number of cores, or basically what we call as vCPUs. So I think it's pretty straightforward. You just pick a software, run it, and you will see that the TPS number will start to scale with ARM. But of course, what you need to do is you need to just make sure that you allow it to cross the scaling point. As in, maybe for lower scalability, x86 will surely scale because of the turbo mode and all. And but once it crosses that scalability point, you will see ARM continue to scale on all use cases.
All right, understood. So when you're talking from an infrastructure point of view, right? When you have built already a RAID infrastructure for your database operations, now you are moving to ARM definitely for performance. Now, database systems has got its own orchestration layer for the maintenance operations and management and automation and everything, right? Do you see from an ARM engineering or ARM infrastructure production engineering perspective, like something extra will come over? Like, actually, where is the complexity for me? Let's consider a case that there are some piece of my data is in bare metal, which is on ARM powered infrastructure, and some part of it is going to be again on a private cloud with and without ARM, right? So when we all bundle this as a single infrastructure, a single cluster of database infrastructure, right? That means building an orchestration or a management layer on top of it comes with a lot of tools from both the ecosystem. What do you have seen in the production life? How do they manage from a infrastructure operations perspective?
So, since this orchestration layer anyway is above, and ARM do support, or basically this, all kind of orchestrations, which, for example, Dockers or Kubernetes and all, are already there. So there shouldn't be issue what underlying hardware the orchestration is using. And importantly, anyway, if you have two different instances probably running, we have use cases where few things are running on x86 and few things are running on ARM, because maybe customer is in a transitional state and wants to first make sure that things works on ARM. And the communication between the two machines anyway is the normal MySQL protocol. So that doesn't get affected. And orchestration layer anyway is independent of the architecture, so that also doesn't get affected. And in terms of complete ecosystem from orchestration perspective, so almost all vendors, especially whether it comes to Kubernetes, Docker, Swarm, or so, they have been providing all the ports for ARMs, and that's probably should able to take care of all the differences if in case there are any with respect to manageability aspect.
So what do you see? You see more of a hybrid computing infrastructure where ARM takes care of faster transaction processing system, and maybe the older archive data is going to the x86 infrastructure. how do you see this whole ecosystem working? Like, who you see as the ARM's most beneficial data property owners? I'm not talking about industry per se. I'm saying like which part of their business is coming to ARM and which part of that is not coming to ARM. Like, for example, is there someone who is using a columnar store infrastructure, be it like a ClickHouse or MariaDB columnar store? They're not using ARM, or people are in the transaction computing space who are on InnoDB or RocksDB, they're using ARM in a big scale. What do you see is the ratio? What do you see is the difference? Or who is
Well,
benefiting most?
most of the, at least based on my reading and based on what I have got exposure to, most of the thing we are seeing is in fact lot of large customers who actually needs a lot of more, computational powers or a huge amount of data, whether it's in form of big data or even in databases. They wanted to move to ARM, and of course there is a motivation because ARMs are cheaper. So if I'm going to boot like 1,000 VMs versus booting them the same 1000 VM on x86, I could see a substantial difference. But if I'm a
Mhm,
small shop, let's say I'm booting like one or two VMs, and then I would say that okay, I don't care, I am okay with x86, I just pay a few $100 extra. But when it goes to 1000, then it becomes 100K, and that's a
mhm,
significant saving. And
mhm,
in fact, the driving factor also beyond that is,
mhm,
a lot of data generating devices has been ARM. Now, whether you take IoT devices or for
mhm,
that matter, all your cell phones, everything is on ARM. So if data generating are on ARM, then the data processing having them in the same ecosystem would just make them easy to integrate, right? We are talking about
mhm,
something like hybrid. So in a long run, maybe in short run, you will see some kind of hybrid things because people are still getting used to ARM, and it is just couple of years back when ARM kind of, a server class machines were introduced for high performance computing. But in
mhm,
long run, I am sure that a lot of customers who needs more computational power at a cheaper cost will surely come to ARM. And beyond that also, if you look at from an industrial perspective, I think all industry has this some way adoption for or link to the ARM. Okay, so it is
mhm.
not only limited to, let's say, HPC, but I would say all kind of industries wherever there is a need for data processing will have some kind of connect with ARM.
Mhm, mhm, mhm. Perfect. So, do you like to share with us some instance or a story where a customer had 100% x86 and they came to you? They definitely nobody go for a big bang infrastructure migration. You help them to identify what's going to be on a migration on a candidature, and from there you migrate maybe 30%, 40%. And what was the biggest challenge you face? Like, because if you see the migration get complex with the data volume size, right? If you look at typically any infrastructure migration, the challenge is like, one, the transaction processing capacity on a higher side is a challenge. The resident data volume is another challenge. Three is like the migration transition processing, right? Migration transition processing. What I really mean by that is, like, at some point of time there is going to be a switch off going to happen to the to their existing transaction processing system, which is going to be on x86 to ARM. So how do you lay out a plan, like someone who want to do a migration from x86 to ARM? Maybe you have like 5 points, like you followed these 5 points, and this is like more of a I don't know, on a strategic perspective before the deployment.
So, of course, a lot of customers who would like to migrate, they would like first to try it out, right? So, I would say that is a preparatory phase where you probably set up a slave or, maybe a active master and allow them to play around. And that's where, we have been trying with lot of POCs kind of things. If we say, we internally have been trying to showcase some of the use case that how seamlessly you could actually have a hybrid thing. And this is mainly for the people who want to gain confidence that okay, well, I can set this up and I can play it around, because no one wants
Mhm,
to manually move the data. So
mhm,
whether it is in Docker, and some of the use cases that our team has tried up is like setting up sorry, servers on x86, and so on a Docker, and setting up a normal ARM based MySQL instance and trying to connect them, and challenges in terms of whether they are able to replicate. If there is an issue, we probably are trying to look at into those aspects. So we are kind of trying all possible combination a user probably could think of when they wants to. They probably will do this combinations and try it
Mhm,
out. Now beyond that, of course, when a user think of moving out, of course I think it's going to be a simple, like for example, if I want to add an additional capacity to my x86 ecosystem itself, what I would probably do is like I will probably set up another instance and will start replicating. I think that is how simple moving to ARM would be. You probably boot up a machine, let it catch up, and one fine day you sit, just probably disconnect your x86 server, and ARM start pointing all your queries to ARM, and things should just work, because all of the things are from an outer user perspective, all are same. That nothing changes.
mhm. How do you see the performance difference when it happens on a higher right amplification storage engine, like a log structured merge tree storage engine, like RocksDB? Do you see the difference in x86, maybe a RocksDB and x86, sorry, ARM RocksDB? Do you want to do some comparison? What does like difference look like?
I personally haven't done it, but I saw community did that with MongoDB, and of course, when I say if you keep the cost constant, at least that's how the
Mhm.
comparison was done. ARM continued to scale and continues consistently. I think was beating it by around 20 to 30% across the
Wow. Okay.
use cases for all the things. But for MySQL, of course, I have done that. So in terms of MySQL.
On InnoDB.
Yes, and it's on InnoDB. So I see that, as I said, right, not only keeping the cost constant, if you give the same number of CPUs
Mhm.
or cores to ARM and to x86,
Mhm.
it may come as sweet surprise to some of you, but then you will see that on ARM is able to scale consistently
Mhm.
and beat x86 with higher scalability, and that the percentage with some case is almost more than 40-50%.
Wow, wow, that's quite impressive. All right, that's all from me on MinervaDB Athena 2020 fireside chat.
Thank you
This
so
happened to be
much.
a virtual fireside chat. Thanks, man. Looking forward to hear more from you on ARM performance benchmarking. Like I mean, I regularly follow your blogs and you're publishing everything. Quite interesting, man. Follow you closely in the GitHub. Thank you so much for the commitment, what you show on the open source ecosystem. This really makes an encouragement and acceleration to the projects, man. Like this is quite interesting. Keep doing great work.
Thank
Great
you so
talking to
much,
you.
and thanks,
Yeah,
all you guys for organizing this, giving this opportunity.
thank you,
Thank
man.
you.
Thank you.
Bye-bye.
Wishing you in advance Merry Christmas, a great 2021, where we can all go around, meet,
Of course, yeah,
declare
everyone is
Christmas.
looking for years to change now.
Seriously, seriously,
Great,
man.
great.